What we're going to do here is, from the standard form of the quadratic equation, derive the quadratic formula by completing the square. So I believe most of you, or all, should be familiar with the standard form of the quadratic equation and the quadratic formula. Now, a special technique that we're not going to go into detail, but we'll use, is called completing the square. Now, in completing the square, the first thing we do is take our C term, which is this term here, and bring it to the other side, just reversing the sign by transposition. Now, we also want to get rid of any coefficient of our x squared, which is in the place of a here, by dividing out the a. Now here the a's cancel out and we get x squared plus b over a x, and we transposed our c term, so we don't have a c term here. So we need to create a new c term, and we're going to use that technique of completing the square. Now, if we can make this expression into a perfect square trinomial, it will factor into this form. And the protocol we followed is, since our b term is positive, this is positive, we take the square root of that, that gives us an x. Now, to find our b term, we had to multiply these two together, double it, and we got that. So to undo the doubling, we have to take half of this term. So 1/2 of b over a gives us now b over 2a. Now that we have this, we can get our c term now by squaring this term. That gives us our c term. So this will be a plus, and it's going to be b squared over 4a squared. So we're squaring this term. We square the b, get b squared, and we square this. 2a times 2a is 4a squared. Now up to this point, these were equal, both sides. But now we've added this to this side. So to keep it balanced, we have to add this to this side. Now we want to do the subtraction. In order to do it, we must have a common denominator. What is our common denominator here? Well, it's 4a squared. Well, I can multiply this fraction by 1 in some form to make this denominator 4a squared. And it's actually multiplying it by 4a. This now will become, and I can put it all over a common denominator, b squared over 4a squared minus, I'll put it in order, 4ac. I don't know if you can see it, but this is the discriminant that's formed. So now these are still equal. And I think I'll erase this here so it doesn't confuse us. Now what do we do at this stage? Well, we want to solve for x, but we have a binomial that's squared. Well, our technique is to take the square root of this side, which will just give us our radicand, which is x plus b over 2a. And that will equal now plus or minus the square root of all of this. But this part here is a perfect square, so we can take out the square root of this, which is 2a, and what's left under the radical sign then is b squared minus 4ac. And I don't know if you can see what's shaping up here. We want to solve for x, so we just take this term, transpose it, and on that side it becomes x equals a negative b over 2a plus or minus this, which is 2 items over a common denominator. We could put it all over the 2a, and that gives us our quadratic formula. And that was the protocol to get there. Okay, again, you can watch this again if you like. Follow it through. It is a little challenging, but hopefully understandable. All right, let's wrap this up.